problem without graphing it. Hey guys, what did you know already?
X is 5.
X is 5. So how did you get the y coordinate? Explain it to me.
We plugged V5 into the other equation.
We plugged 5, but where? In for which one? Okay. We knew that x equaled 5, right? So when you put 5 in for x, y equals 2 times 5 minus 3, which is 7. Okay. Now, I see some groups get to the answer of 2, 5. Some of them got there legitimately. Some of them got there because they guessed and checked enough to get there. Let's talk through what you did in number 1. You knew that x equaled 5, right? So what did you do with 5? You plugged it in for x. Over here, do we know what y equals?
Yeah.
It equals 4x minus 3.
Doesn't y equal 4x minus 3?
No, y equals -3.
No. Y equals 4x minus 3. So, I don't know. Can you see group 1? They wrote bigger than group 5.
Wow, okay.
You wrote very small.
Yeah, you do like small.
They took x plus y equals 7. And they took the y and wrote 4x minus 3. Do you see that? They, instead of x plus y equals 7, they replaced y with 4x minus 3. Is that a legitimate thing? Does y equal 4x minus 3? Yeah. So now they have 5x minus 3 equals... Wait, did I do that? I said 7 and I didn't write 7. Okay. So what's happening here? 5x equals 10, so x equals 2. How did they get the 5?
Because they added the x with the 4x.
If we plug x back in, I think we can get 5. You guys, this is the method of substitution. Would you please turn to page 139? I am so proud of you. 139.
See, I wrote the name.
Okay, so I'm going to tell you something right now. I am going to tell you that in this space right here where it says notes, we're going to do 2 examples today, and tomorrow we're going to do 2 examples. So I just want you to know that you're going to have enough room for that. And if you don't think you're going to have enough room, then we need to find like an extra piece of paper to write some things on. Are you with me?
Yep.
Okay.
Oh, I was straight.
Okay. So, we are going to do what we call substitution. So when you are telling me, plug in that number, well, plug in that number is a informal way of saying substitute. Okay? So this is the method of substitution, where we are going to take one variable and substitute it in for the other. We want a coordinate, x comma y, that satisfies both equations. So we need to algebraically use both equations in order to solve without graphing, okay? So I want to do example number 1. I would like you to write down 4y minus x equals 16. And I would like you to write down that y equals 3/2 x minus 1. Okay. The first thing I want you to look for, do we have one variable that is already solved for? Which one? We have y equals right here. Do you see that? Well, if y equals 3x minus 1, and here is y right here, what we are going to do is we're going to take y equals 3x minus 1, and we are going to substitute it in for y. Okay? So instead of 4y minus x equals 16, I am going to replace y with 3/2 x minus 1. Why did I put that in parentheses? Because we're multiplying, and 3/2 x minus 1 is more than one term. If we're going to multiply to something that has more than one term, it better be in parentheses. Okay? So now I want you to notice that we have an equation where there's only one variable. In this case, it's x. We only have x's in that equation. Okay? Well, we can do that, right? We can go ahead and distribute. Help me out. What is 4 times 3/2 x? So 6x. Yeah. And then we would have minus 4 minus x equals 16. Do you agree? Okay. So really we have 5x minus 4 equals 16 if I combine like terms. Oh, this is starting to be kind of nice, isn't it? Okay. Well, this is like a 6x minus x.
Oh, yeah.
Okay. So now we can add 4 to both sides, so 5x equals 20. Joey, what does x equal? X equals 4. Now, let's remind ourselves, what is our end goal?
To substitute.
We need an x comma y coordinate, okay? So somebody said 2 coordinates. We need x and y for our coordinate, all right? So our goal is x comma y. Well, we figured out that x is 4. How do we get y? Okay, I have a question. Does it matter which equation I choose to plug x equals 4 into? It doesn't, because this coordinate satisfies both. Now, sometimes one equation might be more efficient for us to use. Like right now, we have a y equals 3/2 x minus 1. Well, we can plug 4 in and only have to do like 2 calculations, where if we plug it into the other one, we might have to do a little bit more work. Not much, okay, but just a little bit, okay? So if we plug this in. Y equals 3/2 x minus 1. 3/2 times 4, we decided gets us 6, correct? So y is 5. Okay. Now, I am not going to hunt through your work for an x equals and a y equals. It is my expectation that you write me a coordinate, x comma y. I want to see 4 comma 5. Okay? Now, do you remember what I said yesterday? We will always know if we got the right answer. Okay? How do we know? Plug it in, okay? And you don't even have to show me that work. I know that you're pretty good at mental math. So if you want to do this in your head, that's fine. 4 times y minus x. So 4 times 5 minus 4, is that 16? That is, okay? Y is 5. Does that equal 3/2 times 4 minus 1? Yeah, that totally does, okay? But you might as well check it to make sure you got it right. Okay? Can I tell you that this chapter is one of my favorite chapters of all time? I love this stuff, okay? And I hope that you can learn to appreciate it at least, okay? Okay, we're going to squeeze in a second example right down below. Okay. So we're going to first just talk about how each of these look similar and how they look different. Okay. Up here, we had one line in almost standard form, and we had one line in slope-intercept form. Okay. What I really want to get at is like up here, one of the equations was solved for y. Down here, what's true? They're both solved for y. So how might we go about this differently?
We'd have to find x.
We are going to have to find x. But what is our substitution going to look like? Group 5. This is sort of how group 5 attacked the try it out problem. Okay. I want you to look back at group 5 real quick. Okay. It looks like group 5, they solved that first problem for y. And then what did they do with each of these? Can you see it? They have y equals negative x plus 7, y equals 4x minus 3. What did they do right here? I know you know. I know you know because you did it, Theo. Can anybody else see what they did? I know you know.
I was in group 5.
I know you are, Camden. Camden, what did Theo do?
He combined like terms.
Not yet.
Plugged it in.
Okay, how and give me a way to describe plugging it in, Theo.
Combine the equations.
Okay, do you see how they're both equal to y? Okay, so answer me this. Does y equal y? Okay, so could we write y equals y? See what I just did there? Uh-huh. I took y and I plugged it in to y. Oh my goodness. Yeah. You betcha.
Wait, is there like a specific order we'd have to plug it in? Because it's like with the
So if you wrote this as 2x minus 3 equals x minus 1, it would be the same as if you wrote x minus 1 equals 2x minus 3. Is that your question, Joey?
Yeah, but would you count it as wrong if we had
No.
quiz?
No, it's the same. Because watch what happens. If we subtract x to both sides, what do we get on the left?
2 or negative
If we subtract x, what do we get?
x.
Okay.
Negative x or x.
And then what happens when we add 3?
So you get 2 or negative.
All right, so x equals 2.
Slash negative.
Nope, because if you did it the other way, Joey, you get negative x equals negative 2. Okay, and so x would still equal 2. Okay, so x equals 2. Has anybody figured out why? It's 1. Whether you plug it into here, 2 times 2 minus 3, or you plug it into here, 2 minus 1, right? Y equals 2 minus 1, y equals 1. Okay. 2 comma 1. What does that mean?
2x. 2 y. 1 or just y.
Okay. What does it mean?
It's the intersect point.
Of?
Both lines.
Okay. This is the intersection point of these two lines up here. And if this is the intersection point of these two lines up here, then when I plug in 2 comma 1, it should satisfy both. Does y equals 1 equal 2 times 2 minus 3? Does y equals 1 equal 2 minus 1? I love it when we get the right answer. Okay? So right now, you're going to experience 2 types of problems. Problem number 1, one of your equations is x equals or y equals. And you're going to substitute into the other one. Or both of your equations are y equals. Or both of your equations are x equals. And in that case, you get to substitute it in to where they're equal to each other. Okay? Now, could you please turn the page to page 140? The 9 problems on page 140, that's your homework. That is your homework. Would you like to get started? Okay, cool.